Limit as x goes to 0 of secant squared of x plus 4 secant of x minus 5 over the tangent squared of x. The first thing we're going to do is try plugging a 0 in for each of the x's. That'll give us the secant of 0 quantity squared plus 4 times the secant of 0 minus 5. All of that divided by the tangent of 0 quantity squared. Now the secant of 0 is 1 over the cosine of 0. Cosine of 0 is 1. 1 over 1 is 1. Secant of 0 is a 1. We have 1 squared plus 4 times 1 minus 5 divided by the tangent of 0 is the sine of 0, which is 0, over the cosine of 0, which is 1. 0 over 1 is a 0, so we have a 0 quantity squared. 1 squared is 1. Positive 4 times 1 is positive 4 minus 5 over 0 squared is 0. 1 plus 4 is 5, minus 5 is a 0 over a 0. We have a 0 over 0 indeterminate form. Resulting from trig functions, they don't match each other here. The numerator looks like a trinomial quadratic involving secant. The denominator does not have any secants right now, but because the tangent is squared down there, we may be able to make use of the Pythagorean trig identity involving tan squared. And it is tangent squared of x plus 1 equals the secant squared of x. Since we have the tangent squared of x alone, I'm going to solve for it from the identity here, and that will give us the secant squared of x minus 1. And we can replace the tangent squared of x with that in the denominator of our expression. The numerator I'm going to leave alone for now, and the denominator I'm going to replace with secant squared of x minus 1. Now we still are 0 over 0. We haven't changed that just yet, but we now have factorable expressions involving the same trig function. In the numerator, the trinomial quadratic, and in the denominator, it's a difference of squares. And so we'll factor those to see if we can cancel the factor, making the 0 over 0. In the numerator, trinomial quadratic involving secant, so we will have a secant x and a secant x. We need two numbers that multiply to be a negative 5 and add to be a positive 4. It sounds like a positive 5 and a negative 1 will do that. And in the denominator, we will have a difference of squares, so that will factor into a secant of x plus 1 times a secant of x minus 1. Now x is going to 0, and the secant of 0 is 1 over the cos of 0, 1 over 1, which is 1. And 1 minus 1 is 0, so it's the secant of x minus 1 that's making the 0 over 0 here. We can cancel those out, so let's go ahead and cancel those. That should have removed the 0 over 0 indeterminate form. I will just rewrite what we have left, which is limit as x goes to 0 of the secant of x plus 5 over the secant of x plus 1. And we can now plug in a 0 for each of the remaining x's. That will give us secant of 0 plus 5 over secant of 0 plus 1. The secant of 0 is 1 over the cosine of 0, which is 1. 1 over 1 is 1. So we have 1 plus 5 over 1 plus 1. 1 plus 5 is a 6. 1 plus 1 is a 2. Those are reducible by a factor of 2, and that will cancel out to be a 3.